Okay, geometry, I'm trying to squeeze this in before I go to bed. Here we go, 4.2, apply congruence and triangles. I can identify and use corresponding parts. So you're going to see a really fantastic abbreviation. CPCTC. That's going to come up later. Good night, buddy. All right. And I can use third angles theorem. Okay, so here we go. Start with the warm-up. When are two angles congruent? When are sides congruent? Okay, angles are congruent. Let's see here. Congruent angles are congruent when they have equal measure. And then sides, congruent sides, when they have equal length. Okay, how about this one? In triangle ABC, angle A is 64 degrees, angle B is 71 degrees. What is measure of angle C? Well, remember how all three angles, 64 plus 71 plus angle C is equal to 180 degrees. Add these two up, subtract from 180, angle C is equal to 45. Double check my math, please. What property is this? If A is congruent to B and B is congruent to C, then A is congruent to C. Transitive. Remember, transitive is like a fancy substitution. Okay? Alright, so now we're starting to run into the crazy lighting issues with this color. And hopefully it'll photograph better. Alright, so here we go. Congruent. Congruent has the same size and shape. And then non-congruent, there's different sizes, different shapes. Okay? So two geometric figures are congruent if they have exactly the same size and shape. So in two congruent figures, all parts of one figure are congruent to the corresponding parts of the others. Okay? So that's the CPCTC. Corresponding parts of congruent triangles are congruent. Alright, so that means this little segment is congruent to that one. This angle is congruent to that one, etc. So now there's some information here that might be hard to read. Given the polygons are congruent. That's what this says, okay? And then right there, put these glasses back on. They are exactly the same. Okay. So also it means that the corresponding angles are congruent. Meaning this angle goes with that one. This angle corresponds with this one. Okay, there's two arcs there. And corresponding sides are congruent. And don't say that all sides and angles are congruent. Okay? I know that's what you mean. So if you say all sides and angles are congruent, no. Say corresponding angles are congruent. Okay, so that's an angle that goes with another angle. Corresponding sides are congruent. So this side goes with this side. This side corresponds with that side. So here we go. I don't know if you can read these letters. This is A, B, C, D. Then we have E, F, G, H. So list the corresponding angles. Angle A is congruent to angle E. Okay, see that? A and E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. How about the corresponding sides? I'm going to have to use the space over here. AB is congruent to EF. BC is congruent to FG. CD is congruent to GH. And DA is congruent to HE. Okay, so one thing I want you to see, look at this. In order, ABCD is congruent to EFGH. Those are the letters that correspond with each other. So A goes to E, B goes to F, C goes to G, and D goes to H. Just like AB goes to EF, etc. Okay, so they have to be listed in order. So that's a very important statement right there. All right, let's look at an example. A lot of information. Hopefully this goes faster. Write the congruent statement for the triangles. Identify all pairs of corresponding parts. This right here is your congruent statement. So there's an arrow. I don't know if you can see that. It says congruence statement. So I'll write it again. Because as soon as you write the congruence statement, it's actually really easy to write out the corresponding angles without looking at the diagram back and forth. You could just look at the congruent statement. So look at this. This is RST. So I'm going to write triangle RST is congruent to. Okay, now R has one arc, so that's going to go to F. S has two arcs, so that'll be E. And then D goes with T. So one arc. So R has to go to F, S has to go to E, T has to go to D. It really doesn't matter what order you put these in. It's just make sure the corresponding parts go in the exact same order. Okay? So identify all pairs of congruent corresponding parts. So angle R goes to angle F. That's congruent to angle F. S to E. And angle T is congruent to angle D. Same with the sides. RS goes to FE. ST goes to ED. And RT is congruent, it's got to be in the same order, FD. So when I keep saying goes to, I should be saying congruent, okay? Those are your corresponding parts. So far, so good. So it's a notation, it's really important. Order matters. All right, next one. Here we go. Example 2. Let's put the light back on. Hopefully it's a little bit better. Okay, so in the diagram, ABCD is congruent to FGHK. So remember, A goes to F. B is congruent to G. Okay, so if this is 136, what's this? This will be 136. Does that make sense? All right, so find the value of X and Y. So let's see here. Let's start with X. So this is a side. KF. Okay, so KF is congruent. Let's see here. KF is congruent to DA. All right, so I know DA is 9, and KF is 3x minus 6. So 3x minus 6 is equal to 9. Add 6 to both sides. 3x is equal to 15. Divide by 3, x is equal to 5. All right, so I found x. Now let's find y. Okay, so angle H goes with angle C. So H goes with C, right? Is congruent to angle C. I know H is 4x plus 2y is equal to 44. I know x is 5, so I have 4 times 5 plus 2y is equal to 44. This is 20, so I'm going to subtract 20 on both sides. And I have 2y is equal to 24, so y is equal to 12. We don't don't know if x is 5. We don't know if it's a degree. Yeah, I guess it would be. It's for an angle. All right, so far so good. Jacob took a piece of fabric. ABCD shown. Okay, so it looks like a rectangle. And he cut it with Andrew Proof scissors. I think I used your names and then I changed it along the diagonal to make a scarf for him and Isaac. Okay, so triangular scarves apparently. Are the two pieces the same size and shape? Well, let's look at this. I'm going to like cut them in half. Well, this is A, this is D, and this is B. Okay, so what's missing here is it says shown is a rectangle. So this should be a little side note. And I know you know a little bit about rectangles. Basically what that means is AB is parallel to CD, right? And AD is parallel to CB. And you have parallel lines cut by transversal, alternate tier angles are congruent, etc. So that means you know that, and also rectangles have 4 right angles. So I have this, and I have this. And I know that this angle 1, if I label it, is going to be the same as angle 4. So this angle is the same as this. And then I know this angle is going to be the same as that one. So now, what I have so far is these are going to be similar triangles because I know the angles are congruent, all 3 of them, but I don't know about the sides. Well, what can you tell me about a triangle or like a rectangle? Opposite sides are congruent, so I know those 2 sides are congruent. I know this side is going to be congruent to this one. And look at this. This is the exact same. Here, DB is the same as DB. That's reflexive. Remember that? So I have 2 congruent triangles. What do you think? Okay. Because of all corresponding parts are congruent. So, example 4. Show that triangle AED is, that's AED, that's this one, is congruent to this one. Well, let's see here. I have these 2 angles. I have these 2 angles. I know these 2 sides, and these 2 sides. What's missing? Okay, right here. I'm going to label this angle 1 and angle 2. I also know that angle 1 is congruent to angle 2 because they're vertical angles. And we know they're congruent. So, all 3 angles are congruent, all 3 sides are congruent. So we have it. That will lead to this one. Notice how this had 2 given angles that are congruent. And we were able to figure out this one, but this helps us. Third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third ones are also congruent. Think about it. If I add those 2 up, all 3 equal 180. These 2 are the same as these 2. That means those 2 have to equal the same also. And that's kind of what's happening here. A is congruent to D, so we have an arc right here and right there. B is congruent to E, so they put 2 arcs there, 2 arcs here. Therefore, C must be congruent to F via the third angles theorem. Okay. Next page. Let's apply this bad boy. Find the measure of angle BNM. I know this might be confusing, but whenever you see drawings like this, split them apart. So I'm going to like pull them apart. We have, this is A, M, N. This will be 40. And then I have B, M, N. Okay, so these 2 angles are going to be the same. So this little angle right here is going to be the same as this little angle. And this has 2 arcs, that has 2 arcs. So if that's 40, this is also 40. And all 3 angles add up to what? So we know that this one obviously is 35. It doesn't look like it's to scale, okay? All 3 angles up to 180. So far we have 40 plus 35 plus m is equal to 180. 75 plus m equals 180. Subtract 75. M is equal to 105. So if this is 105, then that has to be 105. So we want angle BNM. This is also equal to 105 degrees. All right? So far, so good. Ooh, prove triangles are congruent. So here we go. Another round of proofs. Alrighty. Whenever you have a picture, take a look at it and start applying. So first of all, AB is congruent to AD. So I'm going to mark that. And BC is congruent to DC. Okay, so I have those 2 on there. Given. Then, AC is congruent to AC. Remember, if something's congruent to itself, it's reflexive. Why are they doing that? Because remember I told you, split that picture if you need to. Okay, so we have this, this, and now they share the same line, so now you can separate them 2 different triangles and see it better. Okay, also BAC is congruent to DAC, so BAC, that's this angle, is congruent to DAC, and angle B is congruent to angle D. So this angle is congruent to this one. That's given. So last but not least, we have angle BCA. BCA, that's this one right here. I'll put an arc with a line in it. It's congruent to DCA. Why? 2 of my angles are congruent, therefore the third one has to be congruent. That's the formula or the theorem that we just learned. That's the third angles theorem. Okay, are the triangles congruent? Look at this. All 3 sides, all 3 angles. Definition of congruent triangles. There are lots of shortcuts coming up, so be patient. Last page, and this is just basically kind of summing it up. Properties of congruent triangles. We have reflexive. Triangle ABC, congruent to triangle ABC. There, it's better. Symmetric. Triangle ABC is congruent to DEF, DEF is congruent to ABC. They kind of swap. Transitive. ABC is congruent to DEF, DEF is congruent to JKL, then ABC is congruent to JKL. Okay, so this is your fancy substitution. So everything that worked with segments and angles also work with triangles. There's our homework assignment and our standard, and everybody have a very nice evening.